So that's what we want to get into today. As far as your assignments go, I'll be grading your hands-on test. Please make sure that you have everything there committed and ready to go. As far as the plan for the final project, I put out the updated kind of requirements out there. But the plan is that you're going to continue with that project that we just started last week. So the project that you started for Hands-on Test 7 is going to turn into your final project. So we've already started on that. Like, well, that would be a good place to go. Everybody's kind of got a project that we can continue on with that. So that's the plan, that's the thing that you'll be turning in as your final project on the 18th, doing a demo with and such. So the requirements are out there. If you look on Inside Rankin, go pull this up. Go to coursework. If you scroll all the way down to the last unit, Unit 10, you should see one for the proposal. You should see assignment for the presentation. You should see one called Final Project. I would start there on the Final Project assignment, read through that, and then go look at the other two. Okay. So what we want to do today with user accounts, I'm going to go over the theory first, and then we're going to kind of go through and start adding some of this functionality to your project. Okay. So if you would bring up the slides that I've got here, they're back on the main page. They'll be under Unit 8. So you can either click on the actual link here, and that will get you a download as a PDF, which you can use, or if you follow the Prezi link here, that will get you into the actual presentation that I'm running. So that's how you get to the slides. Any questions? Okay. So objectives for what we want to hit on today. We want to get you to a point where you can build websites that require login to access certain functionality. We've already done some of that stuff with forms authentication, but we want to do that now with what's called Identity Framework, which is a newer system that Microsoft has built for doing logins and accounts as such. So we'll also look at assigning roles to registered users in this process so that different users can have different permissions. So you may have one person that's an admin and other people are regular users, or you may have different people that are kind of in between. Say, you know, an author and a reader and an admin. Okay. We'll also look at restricting what those users can do based on their role, and then kind of limiting what they can see as far as and where they can go, again, based on that role. Okay, so terminology bits, kind of jumping in there. As far as if you think about the real world, we've got locks on our houses and cars, right? And what's the reason for that? Why do we put those locks on there?
To keep people from entering.
Okay. That's good. That's a good start.
To protect what's inside.
Protect what's inside, right? And in some sense, yes, you keep people from entering, but we're not keeping everybody from entering, right? We're still letting ourselves in. We're still letting people that we want in, but we're keeping people out that we don't want in. That makes sense? So we're restricting who can get in to some people and preventing it to get from other people. Okay, so some people can get in, some people can't. And specifically, if it's just a simple padlock, right, if you have that key, then you can get in, right? So it's a very simple sort of system. If I have the key, I can get in the door. If I don't have the key, I can't. I can still get in there with a pair of bolt cutters to get around it, but hopefully I make a lock strong enough that people won't just be able to bypass it that way. So when we think about that in terms of websites, there's a few different places that can come in, right? That can come in when we're dealing with web APIs, We can think of those API keys or those keys that open those locks, right? So we've got that, but we also have that most commonly username and passwords. When users are trying to get into our website in order to do things that require privileges, we present them with username and password to prove that they are who they say they are, right? So not everybody can get in and change all our data. Does that make sense? So that's part of why this stuff is important. So in terms of terminology, we have this word we call authentication. So authentication is the process of identifying yourself and proving that you are who you claim to be, right? So I don't want it to be my website to be in a place where I can just pretend to be Dalton and get in as Dalton and have all his admin permissions, right? I don't want Jeremy to get in as me and have all my permissions, right? So at some point we have to prove that you are who you say you are, right? So the most common place that we see that, we use a username and password to say, this proves you are who you say you are, right? What are some other mechanisms that we could use to prove your identity?
Could API keys be one way?
That could be one way. Yep.
Two-factor authorization.
Two-factor authentication.
Yeah.
Again, authentication versus authorization. We'll get to that in a minute. Authorization is actually something different. They're easily confused, but they're two very different terms. So, but what does that mean? What does two-factor mean?
When you're logging in or changing settings or what have you, you'll get like confirmation to an external source, whether it be your phone or your email address or like whatever.
Right. So when we talk about two-factor, what we mean is we're authenticating you twice, right? We're using two different means of authenticating you, right? So any one of those is an authentication mechanism by itself, right? If I send a code to your phone, that's enough. You're already authenticating with that system. If I send a code to your email, that's an authentication system. If you log in with username and password, that's authentication, right? So what we're doing, anytime you see two-factor, we're taking two methods and putting them together to make the system more secure. Does that make sense? So two-factor by itself isn't really an authentication method. It's two of them put together. Okay? So what else can we use for letting a user into a system? So we can use, let's see what we got already. So username and password. We've got an API key. We've got security codes, which you might send to a phone, send through text or email. What other things could we do? I'm sure there's a few others that people use on a daily basis here that aren't on that list.
I don't know if this is what you look for, but like security questions?
Okay, so security questions, maybe. When do those usually come up?
When you can't remember your username or password?
Okay, so in that case, we're using it as a fallback authentication method, right? We're falling back because you don't know your password. We're using security questions instead. Your bank, for instance, might actually also use, another government might use those if they haven't seen your IP address before. So that's the other case where that comes up.
Face and Touch ID.
Yeah, there we go. So biometrics, right? So we can do facial recognition, we can do touch, or fingerprints really. We can also do eyes, right? So all of those things can be used in some systems. We'll look at your face, we can look at your fingers, we can look at your eyes, and from those we can prove that you are who you say you are. right? So all of those are authentication methods. There's some other ones. Let's say, how many of you played WoW or any Blizzard game? Okay, how does their two-factor authentication work?
I don't know, I don't use the two-factor.
It's when you sign in, they send you an email.
Okay, no, it's something different.
I'm pretty sure it's over email, yeah. If you sign into like a new PC, it'll send you an email.
Okay.
But I'm pretty sure two-factor, I think it's with your phone.
Okay, it's with your phone, but it's something different than what's on the list. Okay? Steam does the same thing if you've got two-factor authentication turned on. You remember there's this thing called Steam Guard?
It texts your phone number.
Okay, that's, yes it does, but that's without their without Steam Guard turned on. So they have the Steam Guard system. Blizzard has a similar system where you actually have to have an app on your phone, right? They call it an authenticator app, and you actually pull the code from there.
And the code refreshes every couple of seconds.
Yes, correct. So there's the app, and it refreshes the code every couple of seconds. You have to have that app and be signed into it to prove that you are who you say you are. So that's another thing that websites use. That's mostly been gaming websites that have done that mostly, but there's no reason to say your bank doesn't have some value of having a system like that too. There's also, similar to the authenticator apps that they have for Blizzard or Steam, there's also little key fobs that can do a similar thing, where they generate a time-sensitive code that's on a rotation. So there's also actually fobs like that that will generate codes like that. Usually they plug in via USB, some of them just have a digital readout that you can see the code on. So all of those things exist, right? And again, we're talking about two-factor, really we're just usually adding, we're saying, well, username and password by itself is not all that secure, right? Somebody can get your password, so let's use another mechanism to prove that you really are who you say you are. Does that make sense? That's what we really see when we're talking about two-factor. But all of this has to do with proving your identity. Does that make sense? It's proving your identity. It's not proving you have permission to do this or that. It's just proving that you are this person. You are this user. Okay? So we see that login password Fortnite. There's what the authenticator looks like, at least at 1.4 Blizzard. We've got eyes. We've got, you think about crossing the border, well, you use passports to prove who you are, who you say you are. So your driver's license in the real world is also some way of proving that you are a particular person. You're proving your identity. Okay. So we can take all that, we can use that as ways of logging in. Okay. You can log in with a thumbprint, you can log in with a password, all of those things. Okay. Authorization, on the other hand, deals with permissions. So now that we've proved that you are Jeremy, you are Alex, you are Dalton, you are Eston, once we've proved who you are, then we need to determine, based on that, what can you do, right? What are you authorized, what are you allowed to do? So that's where we use those two different terms there. We say authentication is proving your identity, and then authorization is, do you have permission to do the thing, right? You can't typically get authorization to do something without proving first your identity. Does that make sense? I can't do something as Eston until I prove that I'm Eston, right? I can't do something as Alex until I prove that I'm Alex. Okay, so usually we have a login process that takes care of that authentication, and then we have some sort of way of doing authorization. Okay, so you can either be authorized or unauthorized. With .NET, with the identity framework, what we typically use are roles, and that's what we're going to go through. Okay, there's also a system in there that's a little bit more sophisticated that deals with what we call claims, and that's a little bit more granular permissions, but what we're going to be dealing with is roles. So a role is a group of users, right? And the idea is that everybody that has that role can do the same things. So we say everybody that's an author can do X, Y, and Z. Everybody that's a site admin can do A, B, C. So we assign those permissions to roles. Does that make sense? And a typical rule in there is that any user can have more than one role. So you can have an overlap. If you have role A's and role A and B, anything that A can do, you can do. Anything that B can do, you can do. You get both. Does that make sense? So you can kind of wear a bunch of hats. Every hat gives you a different set of permissions.
So when you're using the authorized attribute?
We are really doing authorization, right?
Right.
What it will do when I put the authorized thing on there, remember if you're not logged in, it will ask you to log in, right? It will ask you to authenticate, right? So if I just put the authorized attribute on there, I'm saying, in order to use this, you have to be logged in, okay? There's a different usage, which I'll get to in a minute here, with the authorized attribute, where you can say only certain roles. But right now we're saying anybody who's logged in, okay? There's also another attribute that you can say, well, allow anonymous users, because you might want to allow anonymous users to see your home page and your, your login page and things like that, your registration page. Does that make sense? As far as roles are concerned, they're a group of users, and that's typically how we do assign the permissions. Okay. One kind of side channel here. Once we start talking about users, we really have to talk a little bit about encryption, because if you have all these systems in here but you have no encryption, you have no security. If you don't put any encryption on your website is insecure. Okay, so 2 layers of that you have to have. One of those is going to be you have to be running your website over HTTPS. If you have a login system, you really have to be running over HTTPS. HTTP by itself is completely unencrypted. So any traffic that you do over HTTP, anybody sitting at the coffee shop, they can see everything that you're doing. And they can read all the data that's going around. So you want to make sure that first and foremost that you've got an HTTPS running there. Important thing to know in order to do that, HTTPS is short for HTTP over SSL. So you have to have what's called an SSL certificate in order to be running that. Now, when we're working with Visual Studio, you'll notice the projects that we started have automatically had that set up, right? Automatically had that set up to run over HTTPS. Because when you install Visual Studio, at least current versions, it automatically generates an SSL certificate, puts that in there, tells Windows to trust that certificate. So that when it sees that, it says, okay, you're good. You're really who you say you are. Okay, so that's part of what the SSL is about proving, is your website is actually your website, not somebody else's website. So that's an important thing to know. When you go to actually launch something, typically an SSL certificate is something that's a yearly fee, maybe $200 a year. So that's something to know. As far as hosting a website, that's something you have to pay for to prove, to make sure that those connections are properly encrypted. You can still get encryption without paying for that cert. But what it means is that there's that green padlock that shows up when you visit your website. Okay, so that's one part of that. The other part that's important in there is really making sure your passwords are encrypted in some way, shape, or form, right? You don't want anybody to be able to get into your data, even your own developers, even your own employees, and to be able to see your users' passwords. Does that make sense? If I can log into the database, I shouldn't be able to see your password, because a lot of people at your company are going to be able to log into your database. You limit how many that is, but it's still too many. So we want to make sure that those passwords are encrypted. Okay, so that's part of why I want to talk about some of the terminology here and kind of go over those pieces, especially talking about how do we deal with passwords. The identity framework by itself will deal with a lot of that for us. It will go ahead and encrypt those passwords, but I want to kind of talk about how that works so you're at least familiar with it. Okay, especially once you go to other technologies, it's very likely that you're going to need to know how to do that. And that won't be provided for you. So, general definition, encryption is a method by which we convert information into a secret code. So in terms of hiding the data, okay? Science of that we call cryptography. Cryptography's been around a long time. Cryptography goes all the way back to the Romans, for sure, and possibly earlier. So it's been a science that goes a lot. It's been around a lot longer than even when we've had computers. So there's a lot of theory around it, but there's some things specifically to know, especially when it comes to computers. Unencrypted data, we call that plain text. Encrypted data, we generally call ciphertext. So you'll see those two terms. Any formula or algorithm that we use to encode or decode that text or that data, we call an encryption algorithm or the cipher. So an encryption algorithm will take it from plain text to ciphertext. It can also take it from ciphertext back to plain text. Makes sense? To encode and decode. Encrypt and decrypt. Okay? There's a few different kinds of algorithms that exist out there. The oldest one is what we call symmetric encryption algorithms. And what that means is the way you encode the data is the same way you decode it, right? Or if you have the ability to encode it, then you can also decode it. Does that make sense? If I have the knowledge, the known secrets to encode it, I can also decode it, okay? So the oldest one of the oldest ones that we know about there is something called a Seaver Cipher. You heard, just by a show of hands, who's heard of a Seaver Cipher? Also known as ROT 13. The idea was you take a letter and you shift it on the alphabet to something else, right? So I say, well, I'm going to encode it one shift away, so A becomes a B, B becomes a C, etc. And I can shift that anytime at any number up to 26, right? So from 0 to 26. So you might see a gadget like this that they kind of have turned where you match up a letter and a number and you can see the shift in that little box, right? So if I want to encode it, let's say I'm shifting it forwards to, how do I decode it?
Shift it back then.
Shift it back to, right? So by virtue of that, if I know how it was encoded, can I also decode it? I can also decode it. So it's what we call symmetric, right? So encoding is shifted forwards, decoding is shifted back. So that's usually how most symmetric algorithms work. You do it, and then you do it the reverse way to get the same thing back. You can also do a very basic symmetric cipher by using something called XOR. I don't remember if you've seen that too much, but if I take X, if I remember right in C#, XOR is that operator. And let's say I XOR it with some number. That will effectively flip every bit that's in this number. And then I can XOR again. So that gives me an encrypted data. I can XOR it again with the same number, and that will give me back the same thing. That's not a very secure way to encrypt data, but it's very fast. Does that make sense? So that's one way to do it, and in that case, again, it's symmetric. Okay. So that any symmetric algorithm that I have, I can always get the data back. That's one upside. If I encrypt it, I can always decrypt it. But if I know how to encrypt it, I also know how to decrypt it, right?
So in what situations would you not want it to be symmetric?
Right. That's a good question. Okay. Where would I not want it to be symmetric?
Wouldn't that be easier to correct?
Potentially.
Like if you figure out one piece.
Well, it means that it is crackable. It means that it's crackable, and it means that it's of the options above, it's the easiest one to crack.
Well, because like if you're encrypting a password,
yeah,
onto your database, like in your database,
right?
Well, you need a. Doesn't that need to be symmetric?
No. We'll get to that, but no, it doesn't. If think about it this way. So if I'm encrypting with a symmetric like Seaver Cipher, right? And let's say I'm going to encrypt all my password as ROT13. I'm going to rotate 3 degrees and save them in the database. How easy is it for an attacker to decrypt that data? Fairly easy, right? And in fact, it's easy for anybody to get in there and get, right? So no, I don't want to use a symmetric cipher for passwords for sure, because then somebody could easily get in the database and have all my passwords for every user with very little effort, because they just need to know whatever that secret number is, right? And then all the data is public. So if they know that I've encrypted it with this algorithm or that algorithm, then it's not public. Okay. Now, other places where we do use that, and we don't use Seaver Cipher obviously because it's not very secure, but we do use something called AES, which is a symmetric cipher. Originally, it was developed by the government for actually hiding classified information. So it's the original origin of it. It's actually based on this XOR stuff. It's a little bit more sophisticated than that, but it is based on that underneath because that's fast. So it's actually very fast, and originally was used for pretty much all Wi-Fi traffic, as well as for a lot of the SSL traffic. There's other options now, but it's still one of the ones we use. So in those cases, why do we use AES? Well, in that case, let's say I'm sending data over Wi-Fi, well, I need to be able to unencrypt it on the other side, right? If I send it to your website, you need to be able to, if I send it to the router or your modem or whatever, that needs to be able to unencrypt it. That makes sense? So in those cases, we need to be able to easily do that, and it doesn't matter if I can unencrypt my own data, because this is the data I'm sending. I don't care whether or not I can unencrypt it or decrypt it. Okay. So does that make sense? That's oftentimes places where we use symmetric cipher, where we're sending symmetric algorithms is where we're sending data along, where we want anybody involved to be able to both read it and encrypt it. Okay. So the question of passwords is one. There's another option out there that works out. Okay. So as far as that's concerned though, passwords, yes, I really don't want to save them in a symmetric cipher, but could I save them in AES? Could I make that work? I could, right? I could use a symmetric cipher there, but I really shouldn't. Another option that we have is something called an asymmetric cipher. So an asymmetric cipher is often what we call a public-private key algorithm. There's one key to encrypt and another key to decrypt, right? So symmetric algorithms use the same key to encrypt and decrypt, but an asymmetric use one key to decrypt and another key to encrypt. Okay? Oftentimes these use very large prime numbers, and that's part of where these are the ones where, if you've heard anything about quantum computers, these are the ones we're worried about when it comes to quantum computers. Okay? So when we're dealing with these, generally one of those keys is kept private and the other one is public. You can easily find that information out. It's public information, right? So you know what? One of those you keep secret, one of those you keep public. That's where we have this idea of private, public. Does that make sense? Okay. So with SSL, when we're working with SSL certificates, what's private is the encryption key. What's public is the decryption key. So only you can encrypt the cert, but anybody can decrypt the cert. Okay. If I'm sending, however, a message to a server, it's usually the other way around. They give me the public key to encrypt it, and then they keep the private key to decrypt it so that nobody along the line can read it as it's going from me to them. That makes sense? So it's not always true that the private key is for encryption or the private key is for decryption. That changes. Okay. So let's think about that for passwords. Okay. So this means they can still be encrypted and decrypted, right? It may mean that they still need that private key to decrypt it, but it means there's a private key out there. If you have that number, you know everybody's password. That make sense? So these algorithms we use a lot anytime there's two computers that need to talk to each other and they don't have a previous relationship of trust. So for instance, your browser and the website we're going to, right, you don't already have some sort of secret key to encrypt data. So we use this to take care of that, to generate those secrets so that we have a relationship with them. And we use something called Diffie-Hellman exchange, key exchange, to make that happen. Okay, so that's usually what you use to set up that secure connection between your browser and the server. Okay, so that nobody can come snooping on that there. RSA is one of those that fits into that. I forget what some of the other more recent ones are. The RSA is kind of one of the well-known asymmetric algorithms there. Okay. There's a third option that we have. So both of those are two-way encryptions, right? We've got symmetric and asymmetric. They're both two-way. You can always encrypt and decrypt, okay? We also have something called hash functions, which are one-way, okay? And that's actually what we want to use for passwords. Now let's go through, though, what is a hash function? So a hash function formally is defined as a function that maps an arbitrary length of data down to a fixed length of data, okay? So the data you put in could be any size, right? It could be a large Word document, it could be a text file, it could be a password, right? But what comes out is always the same length, okay? And it's usually shorter than the input most of the time. So let's say I take a whole Word document, I put it into this hashing algorithm, it's going to give me a short number, okay? And we actually see this on ISBN numbers as well. So if you know anything about ISBN 10 or 13, that last digit is what we call a check digit, and it's calculated based on all the previous digits. That makes sense? So you take in all the previous digits, that gives you the last digit, which gives you a way to check that there hasn't been an error along the way. Okay. So a simple hash function might be something like this. Oh, there's a typo there. That should be X. So I take a simple function and it's just X mod 10. Okay? So any number I take in is it's whatever number I get in, it's always gonna end up with a number 0 to 9. Make sense? I can take any number, any positive integer, and map it to a number from 0 to 9 with that simple function. That make sense? So, in fact, a lot of these hash functions typically have some sort of modulus in them to kind of enforce that, hey, I only want it in this range. Okay? So if I take that, let's say I take f of 13, what's my hash going to be? If I take that modulus 10.
3.
It's going to be 3, right? If I take f of 15, I'm going to get 5. If I take f of 25, I'm still going to get 5. So any number I take in will map to a smaller kind of group of numbers. Okay, but you'll also see in there, this is a thing that always happens with hash functions. There are collisions. There are cases where two inputs give the same output. That make sense? That's true of any hash function that exists. As long as your input can be larger, or there's more options for your input than there are for your output, this is always a possibility. Okay, which practically that does mean, as far as when we're using this does mean technically there can be more than one password that actually authenticates you. But it more than likely means that wherever that other password is going to be garbage. There probably is one out there, but good luck finding it. Okay. Good luck finding a password with the same hash. It's usually not that easy. Okay. So what that means is, let's look at this. So I've got f of 15 is 5, f of 25 is 5. Do I have any way of figuring out, given this hash, what the original input was? I have no idea, right? If I have this 3, I don't necessarily know that the input was 13. Could have been 13, 23, 33, etc., 303, right? So I can't easily go from here to there. And in fact, these algorithms are usually a lot more complicated than this, right? So traveling back from here, I've got this random seeming number at the end, back to what the original data was, is basically impossible. That makes sense? So I have this random number. I can't go back and figure out what your password was. That makes sense? I can't just run an algorithm on that hash and say, okay, here's the answer. So this is what we're going to use really when we store passwords. We're going to use a hash because you can encrypt it, but you can't decrypt it. Okay. Now, how do I use that? Given that I can't decrypt it, how do I figure out that you have the same password?
Put the user's input for the password field into the same hash function.
Correct. So because what I know is for any given hash function, whatever I put in as the input, that always has the same output. So I know if I run if you give me 23, and you originally, when you signed up, or when you last changed your password, you gave me 23. I know that as long as those two things, the hashes are equal, then the original password's the same. That's the assumption.
I'm losing it somewhere.
Okay.
So like, where did the 3 for 13 come from? Like, how did that come out to 3?
So,
right.
13 mod 10.
Oh, okay.
What's the remainder? The remainder is 3.
Okay.
Right. So whatever I put in as this hash function, the assumption is whatever hash comes out, if the hashes are the same, then more than likely you probably put in the same password. That's how we do it. Does that make sense? So we don't have a way to go backwards. We can't decrypt, which means the user can't get the password out. Okay. Now, for small things like this, for very simple hash functions, that doesn't necessarily hold up. So for very simple hash functions, what you can actually do is create something called a rainbow table, which means you take all the very common passwords, you say, what are the 10,000 most common passwords, which there's a bunch of ways to find. You go grab that list, you run your hash function, all of it, and you save that as a file. So you've got, here's the password, here's their hash. Well, then you go through that file and say, oh, well, I've got this hash. Is it anywhere in the file? Well, if it's in the file, then, okay, there's your password. Right? So for simple hash functions, there's a little bit of a problem there, right? Because you can go back to, you can generate all of those hashes, this very large file, and then go back. So one of those algorithms that was used originally for that was used kind of in early days, and unfortunately there's still some developers still using it, is MD5. MD5 was originally intended as a way to hash files and prove that, oh, I send it across the internet, make sure that the file got there intact without any of the data being changed, without it being corrupted, which it's still useful for that. Problem is MD5 generates a very short hash, and it means that you can very easily attack it with a rainbow table. You can generate all those, take all the passwords, run that, go back and forth. So MD5 is one of those options that exists as a cryptographic hash. You don't want to use that for sure, absolutely don't, because they will get your passwords. A newer one that exists out there that's more complicated is something called SHA-3. You can get to it through the standard .NET libraries. That one's actually built in. So that's what you want to use. Okay. So the whole idea with these cryptographic hashes is what we call them. And they're basically the same idea, but the goal with a cryptographic hash versus just a regular hash is first of all, if you change any one letter, it should change the entire hash. Make sense? So if I change an A to a B, every digit of the hash should change, ideally. That's important with a cryptographic hash. It also means that collisions should be very rare. So two passwords having the same hash should be a very rare thing. So those are kind of criteria that we use to determine what's a good hash, as well as determining, well, how easy it is, given this hash, to reverse it. Right? We want that to be impossible as much as we can. Okay. Does that, any questions there? Let's just go through an example real quick with MD5, and maybe that'll help a little bit. So if I just go out on the internet and look for MD5 hash, there's a bunch of websites with this code. It'll take that data and generate a hash. Does that make sense? So that this comes into the MD5 algorithm, and I get a random sequence, a random number out of it. You'll see in there that there's numbers and there's some letters. That's simply by the case that it's being spit out as hexadecimal. So you'll see the numbers 0 through 9 plus the letters A through F. Does that make sense? If I type in a different string of characters, I'll get a different hash. But I can say, I know for sure if I put in, hi, my name is Bob again, I'm going to get that same hash. Any questions on hashing there? So that's typically what we want to do with our passwords. We don't want to save them as plain text. We don't want to save them using any sort of two-way algorithm to the database. We want to make sure that we're saving them in a way that you can't undo the encryption. Even if you get our database, even if you got those files, we want you not to be able to figure out what their password was originally. Even if you work at the company, you should know what their password is. So one of the things that means is any company that's able to tell you what their password is, what your password is on their website, you should definitely stop using them.
Is that kind of why whenever you forgot your password, they never tell you what the password is? You always have to change it?
Correct. You should always change it. If they have any sort of way to go through forget your password and tell you your password, you know that immediately you should change your password on that website system garbage and never use their service again. Because your data there is completely not safe.
Not even the company should know what the password is.
Correct. That's really, really important. Because even just for simple things, let's say, for a simple reason, let's say that they can see your password some way or shape or fashion, right? So I know your password is my favorite pony, right? Well, that means I can now log in as you using that password and impersonate it. Right? It also means that that data can easily be leaked onto the internet, and now everybody on the internet knows your password. Right? So you can't even trust the people at the company.
Yeah.
With access to the database, they shouldn't even be able to know that, because otherwise they can impersonate and pretend to be you. And then if somebody can impersonate and pretend to be you, then you can't prove that any data on your website was actually done by the person who supposedly did it. As soon as one person can impersonate another person, none of your data is safe or trustworthy. So, jumping over to talking about how does this fit in with what is the system that we have here in .NET that we can use for logins. So the newest system that's out there is something called Identity Framework. Okay, and Identity Framework is built on top of another system called OWIN, which is Open Web Interface for .NET. Okay, so there were previous systems, like there was the Forms Authentication system, and I believe there's a system called Membership after that Microsoft had built. Unfortunately, kind of in the typical Microsoft fashion, those things were very tightly intertwined with all Microsoft tools. It was very hard to replace it with something else. And it was very limited. It wasn't very extensible. So what they've gone to with Identity Framework is try to make something that's much, much more extensible, something that you can have a lot more flexibility to without having Microsoft adding more features to it. That makes sense? Where you can have a lot more of it be in your control. Okay. So OWIN is not something that Microsoft built. However, OWIN is something that was built as far as open source is concerned to try and make these things more open. Okay. But it's what they've decided to build on top of. So in doing this, in working with this, we do have to kind of understand a little bit about OWIN. We don't necessarily have to do a deep dive on OWIN, but you need to understand a little bit of what's going on there, because that ties in with what we're going to do. So OWIN defines a standard interface between the .NET Web Service and web applications. It's kind of the formal definition. And the goal of OWIN is to decouple the server and the application, okay, and encourage the development of simple modules for .NET Web. So the idea being, here's some things that you can build, and then anybody can use it, right? So I can build this system, and then other people can use it without inheriting all my dependencies. Right, so I say I want to use SendGrid for sending emails. I build this thing that relies on sending emails, but I don't tie myself to SendGrid, things like that. Okay, so I can kind of abstract those ideas. So OWIN, there's a lot of kind of fancy terminology, and as you read through the textbook through chapter 13, it'll tell you a little about the history of OWIN. But the big thing you need to understand it as is it's really what we call a dependency injection framework. And that will actually, if you're looking online for understanding how this works, that will guide you more to resources that will explain it better. So what's a dependency injection framework? What problem is this for? So in order to kind of explain that, I need to kind of go back a little ways. So there's a group of principles called the solid principles. Okay? Originally that was coined by Uncle Bob, is kind of how he's, I forget his last name at the moment, but he kind of put a few things together, and we kind of now know it as the solid principles. One of those, the I in solid, is for the inversion of control, I think is what he originally called it. Nowadays other places we call it the dependency inversion principle. And the basic idea is that we take the structure of code that we have where classes are connected to each other and they know about each other, and the whole goal is to flip it upside down, right? So typically, if I have a pair of classes, I've got that marker is basically dead. And so is that. Maybe one of these isn't dead. Yeah. So I've got class A, I've got class B. Okay? So if A either has maybe a reference to an object of B, creates it, constructs it, calls any methods on B, effectively A knows about B, right? If A uses class B in any way, it's got what we call a dependency. Right? B has to exist and has to be defined before A can do its thing, right? And it also means that I can't easily swap out B. If A knows about B, I can't easily swap out and put another class there. So let's say we call this is SendGrid over here. And this is our login system. Right? So for our login system, maybe it needs to send emails to say, hey, this is suspicious, or when you register to confirm that you're you, right? It may need to send out emails, right? Well, if it directly connects to the SendGrid classes, I can't easily remove SendGrid from the system. Does that make sense? So usually what I want to do is invert that dependency, or remove it as much as I can. So what I usually put in, what we do instead, is we put an interface in between. So this is maybe the I email sender. And instead, A uses the email sender, our login system uses the email sender, and this implements that interface. That make sense? So this class here is an implementation of that interface. And this class uses that interface, which means that our login system knows about the interface. SendGrid implementation, those classes know about this interface, but they don't know about each other. Okay?
I don't get why is this better?
It means that I can easily swap out this system for something else, or I can swap out this system for something else.
Mm-hmm.
So this may be one authentication system where it's username and passwords. What if I also want to log in through Google or Facebook or Steam, right? Then I may need to swap this system out for something else. I may need to swap my authentication system up for a different kind of system.
So you can change that out without having to change everything else.
Exactly, right? So I only have to change these classes instead of changing everything that touches it. Does that make sense? I can do a similar sort of thing and make this implement the iLogin system interface. And then everything depends on the login system interface instead of depending on that specific implementation. Okay, so a reminder though, I'm talking about an interface here. What is an interface? we're talking about C#. What's an interface in C#?
Best way I can describe it is it's a collection of abstract methods that need to be used by whatever class implements it.
You're on the right track, not entirely. Essen, do you have a hand up? Somebody else give me an answer on that. What is an interface? You're on the right track. There's a few things missing in that definition.
It's not only a collection of abstract methods, but isn't it a collection of data as well that can be?
No.
Or is that abstract class?
So.
It's an abstract class.
Right.
Right. So an interface is like an abstract class, and in many ways it behaves the same way. The rule with an interface is it can only have method signatures. It can't have data. Right? So you can't have it storing any data. It can define getters and setters. It can say that it has to have these properties, but it can't define the data or how it's stored. It can't implement the getters and setters. It can't have any implementation. It can define what the contract, it basically defines a contract, but it doesn't define the implementation. So I can have things like the IEnumerable interface, which says this thing can be looped over. I can put it in a for loop. I can get an enumerator for it, but I don't know anything about how that happens. Right? Or the iDisposable interface, which says this thing can be disposed because it's got a dispose method, but I don't know anything more about that. Okay, so an interface is really, it's a collection of abstract methods. And typically we define it as an abstract class with a collection of just abstract methods. Because important thing with an abstract class is you can't instantiate it, right? So you also can't directly instantiate an interface. I can't say new IEnumerable because I'd have no way to implement the enumerate method, right? I have to have some class that implements the logic of that and that I can construct, okay? So when I pull this out and I say now class A only knows about the email sender and this SendGrid, this implementation here that knows how to send out the confirmation emails, implements email sender. Now I've got a little bit of a problem, right? Because how does the login system now get that object? How does the login system now get this email sender object? Because it can't say new SendGrid object. Because if it said new SendGrid, well, now it knows about SendGrid.
I feel like, while in this case, wouldn't we want to use an abstract class?
What do you mean an abstract? So remember, so an abstract class, so abstract class versus interface. I can't construct it either way.
Right.
Neither of those objects can I say new. So how would an abstract class?
Well, an abstract class you can still extend or implement.
Okay.
You can have abstract, so you can have methods that are not required to implement when you extend it.
Right.
Right.
Yeah. So you can have some that are extensible, some that are not. One of the things to remember is abstract classes. You can only have one. You only have one parent class. Mm-hmm. You can implement as many interfaces as you want. You only have one parent class, right? So you can never extend to abstract classes.
Right.
So you want to be very careful about putting in abstract classes because of that whole inheritance step. And it's also, the whole point here is I'm trying to disconnect these two objects. I'm trying to do what I call reduce their coupling, okay? Coupling is a term that says how much does one class know about the other, right? I don't want that, ideally I want that coupling to be 0. They don't know a thing about each other. So what I'm saying is I need this login system only knows about the interface. Okay. So that's all it knows. Which means that as far as that object, somebody else has to know about it. Does that make sense? Because these guys can't know about each other, somebody else has to know about them. And that's where my DI container comes in. That's what connects these two pieces. So we tell our DI container that SendGrid implements the email sender interface, and then this class asks for an implementation of that. It asks for an IEML sender. This gives it back an IEML sender.
So you're middleman.
So this middleman knows about both people. Yeah, this middleman knows about both sides, but they don't know about each other. Okay, that's the whole point of the DI container. Is it's act as this middleman between the two. Okay. So let's look at the dependency inversion principle. So it says classes must depend on abstractions, not on concretions. It states that the high-level modules must not depend on a low-level module, but they should depend on abstractions. And that's where, like, this depends on that interface, that abstraction, that idea of something that can send an email, rather than them directly having a connection to each other. Right? So this guy doesn't know anything about how you log in. This guy doesn't know anything about how you send emails. But we can put those two pieces together, those two blocks, and make things work. So at some point, there is somebody that knows about that, but the idea is I keep that to a minimum. And in fact, I can do this in such a way that the DI container is something I can get off the shelf, where it doesn't actually know about anything in those two parts. Okay.
So that's what OWIN is?
So OWIN is that DI container with when we're working with logins and such, when we're working with authentication and authorization. It's that go-between where we give it a few implementations of some base classes, and then it kind of works with helping us put those things together. It also gives us a lot of benefits in terms of testing this. So let's go ahead and let's go ahead and take a break. Come back at 2 and we'll continue here. I've got a few more points to say about dependency injection.
Yeah, I just wanted to know why was it on the absences and stuff. On the absences? I guess I'm making a YouTube video, sorry.
You can usually get into your own self if you look at the attendance.
Mm-hmm.
So there's your numbers. Don't say them out loud, because otherwise they'll be recorded. That's where you're at.
Okay, just
Mr. Numbers.
sure. It was a situation that had happened. I had to stay home.
Friday craziness?
Nope.
Oh, and even in Fairview, nothing happens. It's so legendary. Like Black Friday's dead in Fairview. The most you get is like Best Buy in the mall. That's all that happens. But even the mall's got nothing. The Best Buy was dead this year. They had a $1.7 million goal for Black Friday. Like Thanksgiving Day Black Friday, and they opened at 5 p.m. And I think my friend said they hit about $500,000.
Damn.
Yeah.
That's fucking wild.
Everybody's waiting for Cyber Monday.
Yeah. I mean, the only thing I worry about Amazon.
Was it? No, actually, I did go up to Best Buy that night because they had a really good deal on the Samsung 860 EVOs. The 1 terabyte SSDs. I went and picked one up they were like $110.
Oh, because I got the same one off Amazon. And it was like 86. So.
Was it? That's not bad. I've never seen them get below that, so I was like, well, I'll go buy it.
Yeah, because I've been looking at it for like the past month. And I looked at Amazon, it was 86.
Wow.
And it was like 97 after shipping.
Yeah, I didn't see that. I think it was 103 when I bought it.
About what?
860 EVO, 1 terabyte.
That's Samsung.
Yeah, the SSDs.
Yeah, they're pretty solid. I think I have two, but they're older.
Yeah, I've heard that Samsung's their SSDs are pretty good. They last a while.
Yeah, that's what I have as well.
I was just.
But I think mine are like 250 gig. They're small ones.
I dumped like $1,500 into a gaming PC. I got like a 2070 Super and all this higher end stuff, and then I was running a 1 terabyte hard drive.
Yeah.
So my boot time was like 50, 60 seconds. And I just got tired of that.
And M.2 drives are supposed to be faster than
They are.
SSDs.
They're
So.
they're like a 1 or 2 second difference though.
Well, the boot time, 1 or 2 seconds in boot time, but they're more noticeable if you're doing stuff with video or potentially gaming, depending on the game.
Yeah, I mean if you do some high-end gaming though.
Actually, a lot of times, the things where you see like the benefit of like an SSD or M.2 over a hard disk, just a magnetic, is really any either MMO or open world.
The load times.
Right, because a lot of times when you have an open world game or you have an MMO, you usually have zone loads, zone changes, and in that process, the zone change usually hits on a hard drive.
Yeah, but even that, those are starting to go away. They're trying to do away with load times.
Yeah, well, I know there was one game that I was playing in particular, and I noticed that it was actually, there's one kind of player hub area in that game, and I noticed when I was in there, it would actually stutter as I would actually turn around.
Because it was trying to load everything?
Yeah, it actually turned out, I turned off Superfetch, which is a service in Windows, and that actually got rid of the stutter because, as it turns out, it was loading things from disk as I was just turning around in that space.
It just wasn't loading anything that you weren't looking at yet.
It was unloading everything I wasn't looking at, and then loading it back in, and once it came back into view, because it's just a big space with a lot of players, and so you can see cases there, depending on what the devs have decided to do with different spaces. So it can add up if you're playing games like probably on most FPSs, you're not going to see it in those.
That's usually when I play FPS.
Right,
Because
because they're
really playing, or I
they
don't
tend to
really
be
play
geared
MMOs.
towards small maps where you can have the entire map in memory easily, versus you have other things where like it's not like you can load the entire map into memory.
I don't
Just
even
in space.
I don't really play MMOs. I play RPGs sometimes.
Yeah.
Like I love the Fallout games, and I got
load the entire Fallout world into memory.
Yeah, I got,
or Skyrim necessarily.
I just picked up the Outer Worlds.
Yeah.
Because it's included in the Game Pass, so I definitely that.
Yeah. So that would be, those would be places where you, Outer Worlds, Borderlands 3.
Yeah, I've got those on my SSD because I just took everything off my hard drive and transferred it.
Yeah.
Operating system, all that I downloaded like Mac or Reflect or something to use that to do it.
If you're playing a 2D game or an FPS, competitive SPS, you're unlikely to see it.
Yeah, I played only FPS I play right now is Modern Warfare.
Yeah.
So
Battlefield would be potentially one of those, you know, exclusions because the big maps.
I don't even play Battlefield anymore.
But
Well, I haven't played Battlefield since Battlefield 4. I didn't like 5 or 1. I don't really like EA games anymore though. I think that's like a general consensus in the gaming community. Everybody doesn't really care for EA anymore.
Well, nobody. Well, unless you like sports games,
Yeah.
they've been out of favor for a long time.
Because I mean, I really liked Watchpoint, I think it was called. Ghost Recon Watch. I can't remember. But I mean, it was good, but it was like not great. It had a lot of bugs.
I like getting a lot of indie stuff on Steam.
Dude.
So I'm usually pretty late to the table when it comes to AAA titles, if I get to them at all. But
I bounce back and forth between indies and AAA games. The only reason I got a couple of the new ones is obviously I got Borderlands 3 because who didn't?
For good reason.
Yeah.
I still need to finish it. I've gotten part of the way through.
I beat it, so me and my friends made a mistake. It was like a Tuesday night or something. We were like, you know, let's just finish the game. It was 9 at night. We thought we were almost done because we got like the end mission or whatever it's called. I can't remember, but it's like an end game mission name. And then 6 hours later, it was like still dragging on. The game's got a lot of like just weird things it makes you do just to prolong the story. The biggest reason I got an SSD is because every time I boot up my PC, I get it set up to where Razor Synapse, I think it's called, Discord and stuff like that open up on their own.
Yeah.
And it would like turn on after 30 seconds of booting, and then it would spend another 2.5 minutes just opening everything.
Yeah, I mean some of that's network latency too. So.
Well, with the new SSD, it literally like before I even log into my account, Discord's always open.
Yeah.
Discord used to take 45 seconds just to load. So.
Yeah.
I was invited to a wedding as an invite. Welcome to You know what? I thought golfing would be in my blood, but it's not.
So looking at getting kind of back into DI, dependency injection. I did link an article down here at the bottom, which I would recommend going through and reading, and it will give you some more kind of fundamentals on how all that works. But again, really the idea with DI is to separate those two classes from knowing each other knowing about each other. There's a cartoon here, kind of does some decent idea of explaining. You say, hey, on this person, they said, I need objects A and B, please give them to me ASAP. Your little DI guy in the middle says, cool. Goes to create the two objects and then gives them back to you. You know, that's basically the gist of what the DI does. Is you tell it, when somebody asks for the email sender, here's the object you give it. If somebody asks for this, then give me this object back. Or here's how you create it. Okay. So benefits that go into basic responsibilities for the DI container is it's going to instantiate those concrete implementations. Say, hey, for this, it's going to take care of creating those objects. It also will have to know, you know, here for this given interface, here's the concrete class I create, and it also has to have some way of then giving those objects back to whatever needs them, whatever is using those dependencies. Okay. Benefits of using a DI, they really enable unit testing. There's a lot of unit testing that you can't do without a DI container. So that's really critical. They also allow us to have very loose coupling between our between classes, so they don't know about each other. So it's helpful in those cases. But the big reason why we're looking at it here is that it really helps you to extend and modify an application, especially given that we're using code that Microsoft has written and some code that we're using. So we're having to extend code that Microsoft has written, and that's where this becomes really helpful. Okay, because we need to extend their code. One of the, as far as disadvantages of DI, because DI isn't necessarily a good fit all the time, is if you don't implement it properly, okay? This especially happens if you try to write your own DI container, is you're going to get a lot of performance issues as well as multi-threading problems. And part of that comes down to, if you're not careful about it, you may be creating the object more times than you need to, or you may be keeping around an object longer than it should, which means you have memory leaks, memory issues, but you can also have a lot of issues with multi-threading, because it can mean that multiple threads are using the same object and they step on each other's toes. So make sure that you're really, if you do get into DI, make sure that you're using a framework that's out there, that's well supported, because otherwise you're going to get into issues. So that's where we're using OWIN to kind of take care of some of that. Okay. A lot of, fair forewarning, a lot of DI containers are built on top of singletons, and therefore get all the problems of singletons. And especially a lot of people, a lot of naive implementations of DI containers don't really work around all those problems with singletons. So anything that you read that might happen with a singleton can happen with your DI container. Because it usually means there's some static variable around there that's remembering what objects you created already and what classes go with what objects and things like that. Question?
I was just curious as to the scope of dependency injection. Is this just a universal object-oriented programming concept?
Yes. Yeah. So you'll see DI in any object-oriented programming language, whether it be JavaScript or it be Java or C#. And you could even do DI with C++, although people don't usually do it with C++.
Okay.
So you can see this really in any language out there as a concept. So other good reason to know about it. They can make things a little bit more complex adding in a DI container, especially there can lead to a lot of readability problems, because it's like, okay, well, I'm using this interface, but I don't necessarily know about the object that's over here. So it can even make it hard to kind of follow the code because I have to know what object implements it. So I can't just say go to definition on that method I'm calling. I have to go find the class that implements it. So you do have to be careful with this, because if you're not careful, you get spaghetti, where this calls that, calls that, calls this, and now all these classes are connected in this mess of spaghetti, and it's not really clear what order things happen in or where your problems are. So you do have to be careful with it, you know, when you get into these DI circumstances, because there's a lot of ways to do them wrong. The other thing you have to kind of be aware of, this does typically push some errors that might be compile time issues down to runtime issues. So for instance, if I say the SendGrid, you know, I need to say that the SendGrid object implements my iEmail sender. If I don't do that, then I'm going to get an error at runtime to say, hey, I can't find something that implements iEmail sender, right? But if I was not using this DI, these two would be connected, and it would happen at compile time. It would say, I can't find the SendGrid class, you know. So there are some issues there, as well as working with intelligence. So it's not a hands-on, you should always do DI. You probably should, but you kind of want to be picky and choosy about how you implement it and how much of it you do. So what I want to do now, I'm going to go into Visual Studio, if you would please, and kind of follow along with this. I'm going to create a new project in Visual Studio. Okay, so I'm going to create an Asp Net project, but I'm going to create it differently than what we've done before. So I'm going to put this in my examples folder, and I'm going to call this user template example. Okay. Don't be careful about going through this, because we're going to do something different on the next screen than what we have traditionally done. So I'm going to call that user template example. Again, it's in the examples folder. I'm going to hit create. When I go into here, I'm actually going to pick MVC, first of all. And the big thing I'm going to do is on the top right, you see the section that says authentication. There's an option here to change. It'll give you a dialog like this. And you'll see there's a few different options. So no authentication is the default, which means by default you don't have any user accounts. Okay. You have also one here called work and school accounts, and you can see that connects you to Active Directory, Office 365, those kind of services that you might see if you're building a application for a business, an internal application, right? So that's not typically something we use for external users, but we might use it if we're building something for internal users, so they can use the user accounts that they already have. Okay. You also have a fourth option here, which is down for Windows authentication. If you pick that, then they're going to be using the same credentials that they use on Windows. And again, that might be their Active Directory account, right? So these two options are something you might frequently see if you're building a website internally that are only used by your employees. Those are pretty good options. But what we're going to do is we're going to use this individual user accounts, because that works a lot better when you're trying to implement something on the internet. So if we want to have user accounts out on the internet, that's what we need. You had a hand up?
What did you name this project?
So I called this user template example. So that's what we want to make sure that we pick. Pick individual user accounts, and we're going to go with this MVC template. Okay. So what this is going to do is it's going to kind of scaffold a basic application, a basic structure of an application. We can look at that and see how some of that is set up. Okay. Because this will actually create a project, a website, where users can already register accounts and log in and log out. So those features will already be there. One of the big things that's missing is there won't be any way for us to do anything with roles or administer those accounts. We won't be able to, from an admin perspective, see a list of all our user accounts, edit them, create them, or delete them. So we won't be able to do anything with that. But
You won't be able to
with this template, right? But when we go through chapters 13 and 14 of the textbook, we'll walk through how to do that. That makes sense? But I want to walk through what you get with this template first.
Which authentication do we need?
Huh?
Which one do we click for authentication?
Individual user accounts. Okay. Don't worry too much about getting the name of the project right, because we're not really going to write any code with this. I just want to show that what you can get out of the box, right? If you start with this. The issue with starting here is that it only gets you part of the way, and oftentimes if you go through this route, it can make it a lot more obtuse to figure out, well, what's the next step to make it work, because it gives you so much code. So we want to kind of see what's it going to look like if we build it from scratch. But so if you run that project just out of the box, right? We haven't written a single line of code, we just created the project. It's already got a home controller, it's already got a home page. This is what it's going to look like. It's using Bootstrap 3, right? Which is one unfortunate thing, means that we'd have to go through and upgrade everything to Bootstrap 4. But this is what we start with. Okay, we start with this in Bootstrap 3. If we go up to the top, we can click Register. Register page, we've got an email, password, confirm password. So I can create a quick email here, Paul Smith, KC. We're going to create that as, you give it password, and hit register. Now, you can see that it's already got some validation in there, even built in, as far as what's a valid password, what's not. Use a different password here. So by default, they have to be, it says at least 6 characters long. They already have to match, and such and such. So we'll go ahead and create that. Okay. So I've created an account. And in fact, you can see I'm already logged in. You see it says hello. I can log off if I hit the log off button. So then it'll go back to this, just register and log in. Let me go back and log in again. So what's built in there already? I've got a register page, I've got a login page, I've got a login functionality. So all of that's already there. I can also click on my name up here. I can get to a change password page, and you'll see there's actually some bits about two-factor authentication and things like that. So there is a good amount that you get just starting out that way. Okay, and we can look at what the code is that is generated to do that. Okay, it's worth taking a look at it. The catch is that there's a lot of stuff that it's also missing, right? So let's look at what the code is in there. So what I want to go to, so there we go. Excellent. So if we're looking at the code that got generated, there are 3 important classes that you really want to look at, 3 important files that you want to look at. So the first one we'll look at is models identity model CS. In app start, there's also an identity config, and there's a startup.auth. So those are the 3 files that really have the core bits of logic that go into setting up authentication. Okay, so let's look at identity model.cs. See what's in there. So if I look at what it generated, there's two classes actually in this file. So the first one is this application user object, which as you can see is a subclass of identity user. Okay? So that's our model class for our users. When we're working with identity framework, we need to create a subclass, first of all, of that identity user object. Okay? So we create a subclass of that. That's what's going to have, if we had any extra data that we needed to add to our users, such as we wanted them to have a first name, a last name, a birth date, etc., that's where we would add this data. Make sense? So that's where we would add it to, because that class represents the user object. Okay, and we'll use this throughout the rest of what we build. Don't really worry about this method right here, generate user identity async. That's something that this actually generates here, but we won't actually do anything with. Okay. The other class that's in here is this application DB context, right? Now, typically when we've created our DB context classes, what have they been a subclass of?
Hasn't it just been DB context?
Just been DB context, yeah. Typically, we're going to make those a subclass of DB context. But look right here. What is this a subclass of? The subclass of identity DB context, right? In fact, you'll see there's a generic parameter here that says, well, what kind of user object are we using? So here we're using a application user object. That's our subclass here. So when we want to work with identity framework here, we're actually going to go change our subclass from being DB context to identity DB context. That make sense? We're actually going to go change what that subclass is. Okay. Also look at what's going on here. We've got a constructor, application DB context. It's got this call to base. That's the base class. Do you remember what this default connection is for? Do you remember what that might be used for?
Is it the name of the connection string?
It's the name of the connection string. So that's where I would put my name of the connection string, similar as we had earlier. There's also a method in here called create. Okay, so public static returns an application DB context create. Okay, this method is for our DR container. This is what we're going to give to OWIN. This is what OWIN uses to know how to create an instance of the database connection. Make sense? So we're going to create static methods like this on here, on our DB context, as well as in some other places we'll see in a minute. But the basic of that, basic situation there, you just say return to application DB context. Unless you have something more sophisticated, that's really all you have to put there. So unless you're pulling like more connection details to how you connect to the database from environment variables or other configuration files, that's really all you have to do as far as that create method is concerned. I'm going to jump back to my slides. Now, one thing in here you won't see right now in the identity model CS class because it doesn't create it. It doesn't create the role subclass, but that's where we would put it. So we've got a subclass of identity user, we call it application user. We would also add an application role, which would be a subclass of identity role once we get into roles. Okay. And those are the same kind of fashion where we don't actually have to add anything inside there, we just need to create a subclass. If we want to add additional properties to our roles table or user table, then we add them as properties to those objects. Okay. So there's our DB context. Okay. So we've got our models, our users, our roles, and our DB context that contains those two things. Okay. The next thing that you're going to see is that we need to create a user manager. Okay. So if you look into identity config, this is under that app start folder. You'll see this identity config file. Inside of there, you'll find this user manager class. So the user manager needs to be a subclass of user manager. It's also genericized there. Again, we put in the specific subclass that we have with the user class. So it's app, it's user manager, app user. And then this, the rest of this is just boilerplate. This will always be here in your user manager subclass. So we'll have a constructor. It takes a user store object, passes that down to the base constructor, and we have this create method that we're going to use for our DI container. So this create the structure of this method needs to return that object. So return app user manager, and it needs to take these two parameters. So the first one is this identity factor options. So it's any options that we need to add when we create it. We won't do anything with that this semester whatsoever. That's beyond the scope of what we're doing here. So you'll need to have that parameter in there for it to work, but you can ignore it for all intents and purposes. So we need that options object, and then we need the OWIN context. The second parameter we do care about. So that OWIN context, that gets us back to the specific instance of OWIN that we're kind of currently working on. That's our DI container. Okay. So if we have here, we say context.get, context get will allow us to then get any of those dependent objects that we need, right? So in this case, the user manager means the database, right? In order to manage users, in order to work with users, we need a DB context, okay? So we're going to say context.get and say we want a DB context that's going to give us back an instance of the database. And then we just construct the user manager with that. So you say construct the user store with the DB, and then you construct the user manager from that user store. The user store is just an interim layer that Microsoft adds, and basically the idea for the user store is it does some caching. So if you need to access the same user multiple times, it will not necessarily have to hit the database every time. That make sense? That's what that's about. It's about trying to avoid hits to the database, but it's also trying to remove that from a layer that we have to directly deal with. Okay? So the user manager just knows how to deal with users. It doesn't necessarily know about how we do caching. That's the job of the user store. Okay? So the user store goes to the database. That's not directly connected to, the user manager is not directly connected to the database. Okay? The role manager is virtually identical. Okay? The role manager needs to be a subclass of role manager. It's got a constructor which takes a role store instead of this takes a user store, that takes a role store. Same thing with the crate. We need to get the DB context and then create the role manager using that role store. Okay. So again, this role manager class won't be in there in that template that we created. But typically we would add it into that file as well. Okay. Now, you'll also find under the app start folder, you'll find a very large file called startup.auth.cs. Okay. This file runs when your application starts. Okay. It runs when your application starts. And what it does is it configures OWIN and it tells it what classes implement the user manager, the role manager, and the database, and the identity context. So the lines of code that are important in there are going to be those three. So it says app, which is which is an argument to this configure auth. So this gets called when the application starts. And it's going to say app.create OWIN per context. Create per OWIN context. So what this does is, so for every person that connects, they get a new HTTP context, they get a new OWIN context. So for every user that comes in, we create a brand new object. We're not using the same DB, we're not using the same user manager, we're not using the same role manager for any two users. That's the way this is set up. Okay? So that ensures that we don't have any sort of multi-threading issues and things like that, making sure that things get cleaned up by making sure that we have a different object for every user. Make sense? For every request that comes in, we create a new object. That's what this says, create OWIN per context. Okay? So we're going to give it now those create methods. That's the static create methods that we gave. Okay? You'll notice here on all of these 3 lines, I call class.create. Right? Do I have parentheses on that crate?
No.
I don't, right? What does that mean? Huh?
It's not a method.
You said it's not a method. Create's a method. All 3 of those are methods. What it means is I'm not calling create at that time. Okay? I'm not calling create on this line. Okay? Because if I called create on that line, there would only ever be one instance of that object.
So what is it saying to do with create?
It's saying give this function off to OWIN and have OWIN create it and call it when it needs it. Does that make sense? So I'm giving it the function.
It's like making it aware.
Yeah, so I'm giving it the function to say call this function when you need a database. Call this function when you need a user manager. Call this function when you need a role manager. Okay? So it will call it at a later point in time when you asked for it. Does that make sense? So I'm not calling create immediately on this line of code, immediately when the application starts. I'm calling it when I need one. Okay? You'll also see some configuration in here. App.use cookie authentication. That deals with how do we save your login credentials. When you go log in, how do we keep track of the fact that you're logged in? So these options say, well, we'll use cookies to store that information. So we'll store a cookie in the browser that tracks you're logged in, and then if the user's not logged in, I've got this new path string. Got here, it says, here's the path to the login page. So our login page is going to be account login. If they're not logged in, they'll get redirected to there. Does that make sense? So that's the basic, we need that, otherwise we won't have a way to deal with, that's the basic setup that we need for logins to work. Okay. So all of those files are generated from running that, from creating that project. Another thing that you'll see in there, let's look at controllers. So we've got the home controller, we know about that. You'll also see that there's a manage controller, okay, with a few things in there. I won't really go too much into, I won't really go into what that's for. The one we really want to look at is account controller. Now, we've already written an account controller, right? When we did forms authentication, we created an account controller. Your account controller is actually going to look similar because we'll have a login method and we'll have a logout method. We'll have a register on there. If we look at the login method here, so on the account controller, doesn't that look the same as what we've done previously? Notice that there's no changes between that version of login that we have versus the one that we've already done, really. You will notice that there's an allow anonymous on here, which we'll come back to, which just says, hey, anybody can log in. So we've got a login method, and you'll see that there's a post method that accepts that login. So what's changed? What's changed is the logic here, right? So rather than using forms authentication, we're using this sign-in manager down here. Similar thing if we look at the register, you'll see it's just a regular register, hey, this is a return view. But then there's some more logic happening in the register, okay? So the basic structure of this is a lot of what you're familiar with. Make sense? But there's going to be some nuance once we start diving into it. Similar thing if we were to go to the view for the login page. Go to view. It's just a form. As far as the front end, the actual login form is no different between a forms authentication versus identity framework. From the front end, it's still the same thing. Okay, so all that really changes is how we do things on the back end. Okay, so those classes that we've covered so far, again, just to refresh, the files that you'll see there which have the important bits of code is that identity model CS, the identity config, and the startup.auth. Okay, that's where all the important code is that's generated from that template. Okay, those are the things you want to know about. Okay, so let's dive into authorization. And we'll come back to authentication and we'll walk through how does that login process work as soon as we get to the textbook, which we'll see if we'll either do it today or tomorrow. But I want to talk about how do we deal with permissions. Okay, so once we get all that set up, once we have all that stuff set up that we looked at previously, now we can start giving the users roles. Okay. And so typically, then we can start figuring out what those roles should do. So if I look at the database, let's go look at the database structure here. Go to SQL, so you want to go to View, SQL Server Object Explorer. If I look at let me check the connection string real quick. So the connection string for this, there it is. So it's pointing at local DB, MS SQL local DB, and it's this user template example. Okay. So if I'm looking under here, you should see you may only have one version of local DB. I have two here. So I want to go though under this one that says MS SQL local DB. That's where I'm going to find it. Okay. Under there, under databases, you'll see that I have this database there. It's running under local DB. That's what it's connecting to. Okay, let's expand it and let's look at what the tables are.
Did you have to create a user for it to show up?
Yes, you do have to create a user for it to actually create the database. If you don't register, it won't actually have created a database here. So there's a few tables that it created. The first and foremost, actually, we can look at the users table, and you can see it's called Asp Net Users. It will always be called that. You don't really have an option, as far as I can tell, to change the name of that. I haven't found it. Okay. So if I look at Asp Net Users, let's look at the code. There's the definition of it. So it already has all of these columns. So just by being a subclass of identity user, we're already getting all of these columns because they already exist. So there's already a user ID, there's already an email, there's already a bit to say is the email confirmed or not. Here's the hashed password. You can see it's stored as nvarchar. There's also this thing called security Scamp, which is something that's kind of generated in there and changes every time you reset your password or do other changes to your account. So that's a randomly generated bit of information. You've also got the phone number. Is the phone number confirmed? Is two-factor turned on? Are they locked out because they entered the wrong password too many times? How many times have they entered the wrong password? What's their username? Now, one important thing that you'll see here, username, email. So both of those columns exist. As far as this template's concerned, what it does is it makes those two things the same. The username and the email in this template are always the same thing. And they don't have to be, and that's where it's nice to build this from scratch because you get a lot more options there. But the way they've set it up out of the box is that those are the same thing. Okay. Now, what might be a case where your username and your email might be something different? Why might we care about the distinction between those two things?
I was going to say, if in some cases you might not want the username to be case sensitive, or like not case sensitive in that.
As a general rule of thumb, neither an email nor a username should be case sensitive.
I was kind of, yeah, I said the wrong thing. It was like if you want there to be possible duplicate usernames, like on Steam.
On Steam, usernames are not duplicate.
On Steam, I've seen duplicate usernames.
We can with Steam as a
You can have profile names that are the same, but you cannot have usernames. So remember on Steam, the username is what you log in with, right? So I actually have a different username than my profile name. If you go to my profile name, it'll show up as Merlin4, but that's not what I log in as. Mm-hmm. So that username does have to be unique. Okay. That's a rule, and that's something that Identity Framework does enforce. In fact, you can see the unique constraint right down here. It says, hey, the username has to be unique. Okay, but notice that there's not a unique constraint for the email, right? So two users, at least according to this structure, can have the same email but a different username.
So it uses username as unique identifier instead of email.
Correct. Yeah. Which is kind of a normal thing. So typically a lot of systems, and this is not what you get out of the box, but usually it's a good thing to have give your user the option to either log in with their username or their email address. A lot of websites let the user do either. Upside of using a username is there's kind of two parts to it. So one is if the username is the primary identifier, then a user can actually create more than one account with the same email. Some websites you might want that. A lot of websites don't necessarily care to have that. You usually want the user only to create one account, so you don't necessarily set that up as valuable. Okay. The other thing that may happen is you may have cases where your users don't really have an email. It's kind of a rare case. We have that with LearnR, which is part of why we need to look at this. But some cases you may have users that don't have an email address. So they can log in with a username, but they couldn't really log in with an email. Okay. One case there might be privacy, right? Maybe you want to keep your users anonymous. You don't want to require them to provide you with an email address because that could break anonymity, right? So that might be one place where they give you a username but no email address. The other case where you see that is working with younger kids. If you're working with middle schoolers and such, they don't necessarily have an email address. They could create a username to log in, but they might not have an email address. So that's part of the reason that those are separate. Does that make sense? Where there's an email address column and there's a username address column. As you're working with this, you'll need to be careful about which you use. Because there's several methods that it's a lot of places where it's easy to accidentally use the email instead of the username or use the username instead of the email. So make sure that you're kind of paying attention to those things as you're walking through here, okay? That the username, so the email does have to be a valid email. The username does not have to be a valid email. There is already a validation constraint built on the email address column that will say, make sure that it's valid and make sure it's required. Similar thing with phone number. Phone number has some validation on it, but the username does not. Okay, so that's the users table. Let's also look at the roles table. So the roles table is very simple. It's got an ID and a name. That's it. Okay. Now in both of these, notice that the ID, there's something very interesting happening with the ID. What data type is there? It's a string, right? So for roles, the ID is a string. For users, the ID is also a string. In fact, if I look at the data, let's look at the data in the users table. Look what I have for a user ID. It's a randomly generated sequence of characters. Why might that be important? Why might they have done that by default? Made the user ID a string instead of an integer.
You can't, if somebody was to get the ID of a user, it wouldn't reveal how many are in the system.
Okay,
Then
that's one thing.
Use an identity.
Okay, that's one thing.
Is it functionally serving the same purpose as just using a GUID?
That actually is a GUID.
Oh, okay.
They're storing it as a string, but it actually is a GUID.
Right, okay.
If you look at the structure and you compare that with what a GUID is, it's the same thing, because you can see the dashes in between the sections.
Oh, that's right, okay.
So it actually is a GUID. It's storing it as a string instead of a GUID, but it actually is a GUID. So yes, they couldn't guess how many they wouldn't know necessarily how many users there are. It also makes it a lot harder to guess usernames, right? I can't just say, well, there's probably a user 5, or there's probably a user 100, and let's just throw that in there and try to play around with that, right? So I can't just easily guess user IDs, which is a good thing to start with. Similar thing with roles. You can get into some security problems if those are simply numbers, right? Where the user can potentially guess what role is which. So maybe they can guess, well, role 1 is probably your admin role. So they figure out some hack to add themselves to a role. Well, then they immediately know which role to add them to. Because it's always role 1. Probably not a good thing. So that gives us some room to make randomly assigned user IDs as well as randomly assigned role IDs. So that's a security constraint. But that's something really important to pay attention to in the structure of the databases, that those two things are strings and they're not primary key identity. It also makes things faster because these tables are accessed quite a bit, and it ends up making accesses and modifications, especially to the user table, a lot quicker. Not as much the roles table, but it does make accesses to there quicker. So there's the roles table, there is the users table, there's also the user roles table, Asp Net user roles. If we look at that one, you'll see it has a user ID, it's got a role ID. This is what we would call what kind of table?
Bridge.
It's a bridge, right? So we've got a bridge between the roles and the users, right? So it's really got, if I want to have a role and I want to have a user, I can just add it to those tables. So let's say I go to the roles table and let's say we want to add an admin role. I could do it directly in the database and say one admin. Okay, we now have an admin role. Simple as that. There's ways to do that stuff through code, which we'll go through, but that's really all it takes to add a role. You just add a row to the table. We now have a new role. Okay, so the name of that role is admin. If I want to add my user that I created previously, let's say I want to view data here, so I can copy my user ID. Let's go to this junction table, user role 1. Okay, I'm now an admin. So by adding in the role, adding in that row into the junction, we're now an admin. So that's how those things are tracked, right? If I wanted to be part of more than one role, I could go to the roles table and say, well, we'll create a tester's role, and now add me again, and now I'm part of both the admin and the tester's role. So anything that I allow admins to do, I can do. Anything we allow you testers to do, I can also do. Okay, so the way that we allow users to do things now is going to be based on the name of the role. Okay, so we don't actually use the ID of the role anywhere in code. We don't want to. We just use the name of the role. So that's the basic structure of that table. Again, I can add in that there. Okay. Now, if I want to restrict access, we've looked at the authorized attribute, and we want to look a little bit more deep with that now. So in order to limit who can get access to certain functionality, I need to add attributes to the controller classes or the action methods, okay? So if I apply, however, these attributes to a method, to an action method, that always overrides my setting to the controller. So the controller is the default for the entire controller. Whatever I apply to the method overrides that. That makes sense? So when I want to apply something to the controller, what I'm going to do is I'm going to add the authorized attribute. Okay, so if I add the authorized attribute to the controller, I'm saying everything in this controller you need to be logged in for. Okay, so for instance, if I have an admin controller which can do sort of administer products, I wouldn't want to say, well, everything in here is only for admins. Or if this is my chat room, I would say, well, put authorize on that chat room controller so that only people who are logged in can get into the chat room. Okay. I can also add that to the methods. When I go to the methods, I have two options. I can either add authorize or allow anonymous. So if I add allow anonymous, that says this particular method can be accessed without logging in. Okay. By default, if you don't apply anything to the class, the default is that all of your methods can be accessed by anybody on the internet. By default, it's anonymous. So typically, if you have a mix of some methods can be used without logging in and some can't, you typically always want to apply to the class the most restrictive set of rules. Does that make sense? So if you've got a mix of some users can do this, some users can do this, to the class, you're going to say authorize, but only allow admins to get in. And then on a method by method basis, you lower the restrictions. But your highest restrictions should be on the class. Your lowest restrictions should be on the individual methods. Okay, so the way this works out, if I want to say only certain roles get access to a particular functionality, piece of functionality, I just add in this parameter roles. So I say authorize roles is equal to admin. Now only people that have the admin role can get to that controller or to that method. If I want to allow authors, well, I just do author. If I want to allow unicorns, I just say roles is equal to unicorn. Now only unicorns can do this. If I want to have more than one role, the way I do that would be like admin, comma, author. You just add a comma if more than one role can do it. But that is then an or, right? So if you say admin, comma, author, then either admin or author can do it. You don't have to have both roles. There's not a way in the authorized attribute specifically to say you have to have both. It's always an or. This role or that role. Okay. If I leave the roles off, that just means you need to be logged in. I don't care what role you have, but you need to be logged in. That make sense? So you can either say you have to have this role, or you can just say anybody who's logged in can get in here. And then again, allow anonymous means you don't even have to be logged in. So this is a good thing. If you're building out your account controller, we definitely want to mark the account controller as authorized, so that you can't just like go to try to change a password without being logged in. So we're going to mark that admin the account controller is authorized, but then we don't mark like the login methods as allow anonymous. Now, typically your get and post methods should always have the same attribute. They should always have the same permission. So if you can do the get, you should also be able to do the post, and vice versa. You want to make sure you keep those in sync, right? So let's say I say that you can get to this page to edit users, right? And then you've got post for editing the user. I want to make, if I say, well, admins can post, but anybody can get, well, that means anybody can get to the get page on the internet. But you only post if you have that. Well, that's still a problem because anybody can see the information. They can still read the information. If I say only apply the authorized attribute to the get, but not the post, well then, okay, to get the page, you have to get to the page in the browser, you have to be an admin. But anybody can post through Postman or other tools, right? So you want to make sure, for sure, both your get and post should always have the same restrictions. Because otherwise you open up a security hole where outside users can either read data or change data that they shouldn't be able to.
What would come back from a Postman, like response?
It depends on what you send back. So if you're returning JSON, you'd see the JSON. If you're returning a view, well, you would see the HTML for that view.
What if you had like a authorized role admin and you don't? How do you?
Yeah. So what happens is this authorized attribute, what it does is it kind of steps in before your action method runs. So before your action method runs, the rule in the attribute, the code in the attribute runs. And it says, if you're not authorized, then return a status code, I think it's 403, which is unauthorized. There's a
that's it. Yeah.
something like that. I think it returns a 403. I remember the exact number. But it returns an unauthorized status. And what happens then is the .NET framework, or OWIN, picks that up and says, oh, you returned a 403 status code, and redirects you to the login page. So the authorized attribute actually returns a 403 status code, and then .NET intercepts that and says, oh, you've got a 403 status code. Let's send you to the login page so that you can log in, passing through that redirect URL. So the redirect URL would be where you were trying to go. Does that make sense?
Mm-hmm.
So what you end up seeing instead is the login page. If you don't pass the authorized, then you end up seeing the login page. But the nuances of that status code thing happening does matter quite a bit. Especially it matters when you're doing AJAX, because that's where you want to capture that 403 code oftentimes. You can read more about the authorized attribute if you follow through that link. It'll give you more about that class. But that's really all we need to know about there. Okay. So that authorized attribute, that will allow us to restrict who can get to pages, who can access methods. Okay. it doesn't allow us, it doesn't give us enough to say, well, this part of the page the user can't see, right? Like they can't see the edit button, or they can't see the delete button, or they can't see the create button, or they can't see the birth date, or whatever it may be. There's a lot of times where we want to hide buttons or pieces of information that go beyond just saying you can't go to a method. Okay? So the way we do that, we're going to add some logic to the views to do that. So we can check if the user is logged in and if they have a role. So if I say request.is authenticated, that gives me a true or false value. It's true if they're logged in, false if they're not. Simple as that. So you can do if else on that all you want and say don't show the HTML, or do show the HTML, do show the button, or not show the button. If I want to say are they an admin, then I would do something like this. I'd say are they authenticated and do they have that role? So user.isInRole will allow you to check whether or not they have a specific role. You always want to combine that with request is authenticated, because this here will throw a no reference exception if they're not logged in, because the user object will be null typically when they're not logged in. Okay. So you always want to combine those two things. If you want to say they're either one role or another, either author or admin, that's the way I would say. Request is authenticated and this or that. So that's how I would check, are they an author or they are an admin. So then I can say, well, if they're an author, then they can do these things. If they're an admin, they can do those things. Typically what I'll do is up at the top of the file, remember there's usually a C# section there where we're setting VBAG title and things like that. This is a good place to put code like that. That way, you only have one place in your view to put it, instead of putting this all throughout your view. That way you only check it once, and you can just use that boolean in the rest of the file. So that usually ends up resulting in keeping it a little bit cleaner, rather than putting that check if every time. Dalton, you're kind of okay. So that's how we prevent users from seeing things that they're not supposed to, from seeing buttons or information that they don't want us, that they shouldn't have access to. Okay, so reviewing what we've talked about there, we'll come back to logging in. We've gotten a little bit of that as far as talking about the login page. We talked about how to assign roles. You saw me at least how I did that through just editing the database. You saw that we went over some restrictions for who can get access to what, using that authorized attribute, as well as using that request as authenticated user is in role to kind of limit who can see different parts of the information. Okay. Any questions here? Hopefully there's some.
Just a lot of information.
Okay.
I think it would be easier to actually like implement it onto an existing project.
Yeah. Well, that's the plan. That's the plan. So what I want to do at this point, what we'll do for today, the rest of today, as well as going into tomorrow, is I want you to open up your final project, or your hands-on test 7, the project that you started working on. Open that up, and what we're going to do is we're going to go through chapter 13 and 14, and we're going to add that into your project that you've already started. That makes sense? I'm going to start with a clean project, a brand new empty project up here, as far as what I do on the board, but I'd like you to start from there. So open that up. I want to make sure that everybody's got things checked in at this point. So if you would, once you get your project open, please open Team Explorer. Push it over to changes so I can see that view. I just want to make sure everybody's checked in at this point.
Explorer changes. Okay, so you have a lot of stuff.
I pushed it earlier through Tortoise, did it?
It's probably just because we created that example project.
Okay.
So, yeah. Make sure you check it. Yeah, so that's the example project that we go ahead and commit that. Nothing changes. You go to Team next door. Any changes?
You're done?
So you need to
Yeah.
check.
Create.
That's the example.
What, did you use a Bootstrap?
Yeah, I did.
Which one did you
I
use?
can't remember if it was like the
So just check that out and see.
something weird.
That's cool.
Yeah, no, I used to.
Yeah, so give that
Yeah,
a comment.
okay. I almost should have.
What's in the user
Yeah.
That's okay. We want to, at this point, we want to have nothing outstanding. Because there's a very good chance that you want to need to go look at your changes and see what changed, what happened. Okay, so if you look on inside Rankin, on the back to the main course page, right next to where these slides are, under Unit 8, you'll find this PDF here, Asp Net Identity Framework. So these additional textbook chapters. You want to open that up. Okay, so this is chapters 13, 14, and 15 for the kind of companion book that goes with our textbook. And it goes over how to do some of this stuff. So that's what we're going to go through. Okay, I'm going to go through chapters 13 and 14 as my goal. I'm not planning to go through 15. You can go through that on your own if you so wish, but all the really core stuff that we need to hit is in 13 and 14. So, starting from there. Okay, so there's a lot of information in here about OWIN. There was an old system called membership that existed before. There's a lot of reading material on there. You can expect that there's going to be some homework questions on the text here on page 1, because there's some history bits in there. Okay. As far as kind of what's covered in here, we can look at what's in chapter 13. So it's going to talk about how to install Asp Net, how to kind of do some preparation, how to go through and list the user accounts, create user accounts, deal with the password policy, validate to make sure user accounts are valid, as well as then deleting and modifying accounts. So that's what's covered in this chapter. Okay, so step 1 here, they say to go install Bootstrap 3. Ideally, we will already have had Bootstrap 4 installed in there. So that's where we want to start. I'm going to go create this empty project here so that I'm at kind of the same point where you guys are. So you'll be working on your final project. I'm going to create an empty project, so that's all that's in here. Okay, it's going to go under examples, and what do I want to call this? Say this. I'm going to call this auth example. So I'll give you all the code for this project that I'm going to do up here once we're done with this, so you can have an example. You can have this as well as your copy of it. So worry too much about that. Okay, so I'm going to create this again as empty. I'm still going with no authentication, so I'm starting at the same point where we've traditionally started.
I don't think you checked MVC, did you?
Oh, did I not? I might need to recreate it then. I don't think I did. Okay, so next, auth example. My examples folder. Create. Yeah. Okay. So MVC checked. There we go. Okay. So let's add a home controller, because that's what we have here. You will likely already have a home controller, so in that point you don't necessarily need to follow along with this. The only purpose of this home controller that I'm creating here is just for some testing purposes. So we can demonstrate what that's going to do, but it won't really be all that important for your final project. So this is going to be the home controller. I'm going to add in the code from the textbook here, which is public action result. So just creating some placeholder data and showing it on the front page. I'm also going to go through and add Bootstrap 4 as well as the validation packages. So I'm going to go to manage NuGet packages and add in Bootstrap 4.
Searching installed.
Right. Well, I think it already, oh no it isn't. So Bootstrap 4, I'm going to go ahead and add that in there. I know I need entity framework, so I'm going to add that in, and I'm going to add in the validation, the unobtrusive validation as well.
What was that code that you put in?
It's just from the textbook. It's it's page 298. Again, you don't need that code. And I wouldn't recommend bringing that in. That's just for some things that they're going to demonstrate here. Okay, so I've got the unobtrusive validation package installed. And there we go. So I got jQuery unobtrusive validation, Bootstrap, entity framework. Those are the things I needed to get in to get back up to pace. I need to add my layout file now. So I'm going to go into here. I'm going to say add a view. Okay. And then this is page 299 is where I'm getting this code. So 299, bring that in. It doesn't specify the model, which is interesting. So let me go ahead and add that model. Dictionary. And then that was a string to an object. String object. Okay, so So that's the code for that view. You'll see if you look at, again, this came from 299. You remember the textbook's using Bootstrap 3. So I do need to upgrade this code to be based off of Bootstrap 4. So panels were something that was in Bootstrap 3 but has then been since removed. So I'm going to replace that with a card. Wrap with div, class, card, body. Okay, so that's the basic rough out there. And I need to update my layout to be what they have here. Again, this is all from page 299. I am gonna remove some of this code here. Style, margin top. Push that down. We've got the container, got that. And I do need to add in my JavaScript then at the end. So script, okay, scripts, jQuery, min, and I want bootstrapped. Bootstrap min.js. I also need jQuery validation. jQuery validate. There. Okay. So big things that I've changed from page 299, just trying to pull it up through Bootstrap 4 instead of Bootstrap 3 for a few things, as well as adding in the jQuery scripts, because we'll need those potentially for a few things. Yeah. Okay. So that's enough for page 299. All right, so looking at page 300, let's run it and let's make sure that we are at the same point. So what I'm seeing is something like this. It's a little bit different than the textbook I can see, because the textbook you can see is blue for the top, because that was the default rendering for the panels. And remember, I had to change these over to cards. So if I want that to be the same, I need to change the background color. So I'm going to change the background color of the header to be BG info. That should change it to be blue. There we go. And I think it was actually white as well. So that'd be text white. Text white. There we go. So basically we've matched it up where we've got placeholder, so we're in the same place as here. Okay. So now that we've got the project roughed out, where you can actually start getting into identity framework and where to hook those things in. So in order to hook in identity framework, we do need to have a database. We're going to go about this a little bit of a different way, so I'm not going to follow exactly along there. If you haven't yet, however, make sure you go to View and SQL Server Object Explorer. Under SQL Server, you'll want to add in this localhost server. Does anybody not have that yet? Localhost listed there?
Kind of just the default localhost.
This should be localhost. Yeah. So that will, if you expanded that, you should see all the databases that you have on your computer. Okay. That will be important in a bit because we'll need to look at those tables that are already there that this will generate. And we'll kind of need to bring over some of those table definitions into our SQL Server project. Okay. So that's how you get to that. Okay. The instructions, if you're looking at this 301, 302, they are a little bit different because they're using local DB. Okay. So because we're using full-blown SQL Server, our directions there are a little bit different. Okay. So in order to get started with OWIN, there's 3 packages that we need to add. Okay. Now, you'll see what's there is there's 3 different commands to run on the package manager console. Okay. Don't run these yet, but does anybody remember how to get to that? How do you get to that package manager console? How do you get that to open up? Where in Visual Studio do I need to get to that? Any suggestions? Yep.
Tools.
Uh-huh.
Tools, NuGet, package manager.
That's it, right? So this is one of the weird ones. Not all windows are actually under view. Most of the common ones are under view, but there are a few like this that are under tools. There's also a few under debug windows, so like breakpoints and such. So there are a few windows that are other places. So open up tools, NuGet package manager, and we're going to go to the package manager console. That should give you a window like this. Okay, that should give you a window like that you have docked to the bottom of your page. Okay, now if we're looking at the commands, you'll see that in the command there's this version 2.0. Okay, the reason that that's there is those are the versions that they tested when they wrote the book. Okay, so they were running with version 2.0 or version 2.1. For our purposes, we really want to run with the latest version. So when you run these commands on the package manager console, please leave off the version number so you get the latest. So what I'm going to do, and you do actually need to run these commands one by one, so I'm going to copy that first command and run it here. So I can run it here by right-click, paste, enter, and it should start running that.
And so we shouldn't do that first one. We already put an entity framework there.
Yeah, it's not actually entity framework if you pay a closer attention to the URL. So the entity framework is just entity framework, but you'll notice that the name of the package there is Microsoft.aspnet.identity.entity framework. So it's actually built on it's actually a package that integrates identity framework with entity framework. So you will actually need to install that. You will need to run that first command because you won't have that package.
think now's a good time for a break.
Yeah, I would agree. So before you go on break, though, just please make sure that you have those 3 packages. So identity framework, identity OWIN, as well as having the third one is OWIN host system web, which I'm not seeing on here. Yeah, there it is. So make sure you have all 3 of those packages installed. Once you do, go ahead and take a break, come back at 3:30, and we'll resume with this.
Was that supposed to break the program?
Huh?
Was that supposed to break it?
I don't think so. I can come over there in a second and look.
No, somebody's out to hang and let's start it back to you.
Yeah, that's right. So hang on there on that.
Cool.
So what, can I see what happened with you?
Can we see what the error
Oh, okay.
It does the same thing, I believe.
Yeah. I just install. Let me do this. You need the same exact thing? Yeah, you did.
Okay, no, that's fine.
It's probably just because it's
Yeah,
not set up yet.
That's fine. It's looking for the startup class, and we haven't created it yet.
Okay, that's what I figured. I was
So
just
we'll fix that in the
making sure I didn't kill my project. Whew.
So this first bit of code.
Delivered.
This has been delivered. Don't worry about it.
I should implement that in the program yet.
That's really just there for testing. It doesn't actually do anything.
I got you.
It's all it's going to do is it makes that placeholder page that you saw. So all of that's for this page right here.
Oh, okay.
So what all that's going to do is it's kind of a test page to make sure that everything's working.
Okay.
And we won't want that to finish.
Oh, okay. I think so, just for testing. Okay.
Yeah.
All right.
Plus all the code that I just put there, I'm going to replace.
Get there.
I'm going to replace that. So
Okay.
don't worry about that too much.
Okay.
Because I'm going to replace that with something else.
Should we go ahead and update everything as installed?
Yes, that'd be a good idea. When you update it, just make sure you update it one by one instead of, because you have the option to say select all packages and update. Don't do that because a lot of these packages don't play nice with each other. So you really have to update them one by one, unfortunately. Do note if you change the version of jQuery, then you're going to also have to change the script tag in your layout. So like mine, I just upgraded it from 3.3.0 to 3.3.3.4.1.
I think mine was already updated.
Yeah.
I had already updated everything else, so.
Yeah. Okay.
was up weird. It didn't have
So if you run the program right now, as you saw, you'll end up getting a error like this. In fact, it's going to kind of give you a hint as to what's going on. So what it says is it can't find an assembly with an OWIN startup attribute, or it can't find a startup class, or a class named assembly named startup, yada yada, or it can't find this app setting. So there's a few different ways to give it the initial startup configuration for OWIN. And in fact, there's a whole article about how to do that. One option is you call the class startup, and then it'll look for that. The other way is you can add this particular attribute to the OWIN config, or you can add this attribute into your web config. So the route that the book goes down is to set this in the web config, which is what I'm going to go do. Now, I'm going to actually still set it just to the default name and just call it startup. Reason being, I think that's still kind of the most common way that you'll see this, is still calling the class startup. So that's the route I'm going to go. So in the, if I open up my web config, and remember we want to open up the root web config, do not open up the one in the views, okay? Make sure this one is at the root. You'll see a section here called app settings, okay? Into there I'm going to add another setting. Add key is equal to OWIN : app : startup. Or no, that's app startup. Should that be with a lowercase? Yes, it should be lowercase. So app startup, and the value is the name of our class. Okay, so that's the line of code I'm adding in there. The upside of putting it here into the web config, all of these things that we got under app settings, these are settings that we can change easily on our server. So we go to deploy it, I can put a different setting in this file, and it'll run a different way in production or in testing environment, wherever it may be. So if there's different things I need to do in startup, depending on if I'm testing it or if it's running live, then I can use a different startup config in those different environments. Okay, so that's the upside of doing it this way, is that it allows us to change that setting and therefore have a production setup or a dev setup, dev startup or a production startup. So that's the upside of doing that. Okay, they also go through adding a connection string, which I'll do here. So also under app settings, you will already have one, so you don't actually need to do this. But you'll want to make sure that your connection string is right. That being said, there will be some settings that you need to add to your connection string that will not necessarily be in there yet. So I'm going to say add name. This is going to be default connection. You will already have one in there with a different name. You'll want to keep that same name. My provider is going to be, my provider name is going to be data system.data.sql client, and now I need to add in the actual connection string. Okay. So remember that we need to set the data source to point to the server that it's connecting to, which for our purposes is ourself. So data source localhost. And I'm going to have the initial catalog. Again, you'll want to use your own database name. don't use the name that I'm using. So initial catalog is going to be auth example. And I'm going to say integrated security is true. Again, you should have all of that so far already. Ideally, there's nothing you have to change. There are a few things in here now that I do want to add. Okay, so the next one is going to be the connection timeout. So I'm going to say connect timeout. So you want to add this to the end of your connection string. We're going to say connect timeout is 15. That will change how long it waits if things take too long, because some things in here may take some extra time. I'm also going to say multiple active result sets is true. That's the really important one to do. By default, your connection typically can only have one select query going. What that lets it do is it allows it to have more than one query in the process of running. So you can have more than one select query running at any given time. That's necessary for some of the code in the book that works with users. So the only thing you really need to change about your connection string is to make sure it has that setting in it somewhere. It may already have that in there, probably doesn't, but make sure that it does.
So we already had a connection string, we just add those?
Just add multiple active result set to true and the connect timeout to 15.
Okay.
So that's all you needed to add to the end. Okay. And again, so we're on page 303. I'm going to hop over to page 304 now. So what we want to do next is create the user class. So we've gone ahead and set up the connection string and set the startup file. I'm going to go to the models folder. I'm going to add a new class. So I'm going to add, this is going to be, go to code, we're going to call this class app user. Okay. Public class app user. App user is a subclass of identity user. Okay. That's all I need for the identity for the app user class. It's just app user : identity user. Okay. Per looking at the user class there, you'll see that there's some properties again there. We already kind of looked at that. Just to refresh, if I right-click on identity user and go to definition, you can see there's identity user. Let me go to definition again. So if I look in here, I can see all of the properties that are already there. So you can see there's already an email property, etc., 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 a username property. So there's already a lot of properties that are already on that object. Okay? But that's all we need to do to get a basic setup. We just say app user is a subclass of identity user. Pull this back over here. And I really would recommend reading through everything here that's in table 13.2 to make sure you're acquainted with all those different columns. including note here that there's a roles property which will let us get access to the roles that that user is part of. Okay. So we have the app user. I'm going to go ahead and add that comment in here from the book. So this is page 305. So we've got an app user. I also need to add in my DB context. So the way I'm going to make this DB context, I'm not actually going to go through that wizard. I'm just going to create a new class. So I'm going to create a new class called app DB context.
This is under models.
This is under models. Do not create this class for yourself, okay? So instead of creating this class, change the DB context that you already have.
Okay.
Because you want to reuse that DB context that you created earlier.
So we don't need to rename that. We just need to.
No, don't rename the class. Just change that it's a subclass of identity DB context instead of DB context. You'll need, you probably will already have a constructor in there. If you do have a constructor, you don't need to change it. If you do not have a constructor, do add one and point it to your connection string, whatever you called it. So for me, that's default connection. For you, that will be another name. Okay. We also need to create that create method in here. Plug public app identity. This is app DB context and return new.
So we do want to have that create.
So you do need to have that create there. Use the same constructor that you had, but you do need to add in that create.
No, but I would put it just right there under constructor. That's definitely the best place to look. Remember to mark that method static. Remember, if it's static, that's going to allow you to call that method without constructing an instance of that. And remember, this is moving for this. Talk about last discussion. Go back to your presentation. The problem is you're in the wrong place. See, this is another property on the tag. This actually needs to be inside of the connection string, which is so we've already got true with it has to show, it's very important to follow the same spacing and capitalization. So connect, timeout, it's actually a space between some of those connected. You see that O should be a focus.
right. So the important two changes that you should have made there, we changed the, again, to be a subclass of identity DB context instead of DB context. That's the big thing that's going to make the most difference. But we also need this create method, which we're going to use in a minute. One very, very, very important note, okay? If you're looking at the textbooks, page 306, okay? There is a class here, okay? There is something very, 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 very dangerous that they're doing right here, and you should never do, okay? Can you see it? We created this class identity DB in it. Do you see what's subclass of?
Drop create database model changes.
So, any guesses as to what that's going to do?
I'm going to guess that it's going to drop the create database model change.
So if you add another column, rename a column, change a table, if you do anything to your schema of your database, this is going to say just drop the whole database and create it again from scratch. Do not do that in any sort of production, anything, even testing. That's a bad idea.
Why did they use that?
They're trying to keep the book simple. That's the gist of it. Is the gist of it is we're going to say, well, just throw away all your data. It doesn't matter because this is just a test simple app. I'm going to assume that your final project that you're working on, you've probably put some data in there and you probably want to keep it. So don't do that. Otherwise, you will have problems. Okay. Now, what we can do, and what would be better, instead of saying drop create database if model changes, there's a different subclass that we can use, which will be a lot less damaging. So that's the one I'm going to put in there. Okay. So underneath my AppDB context, I'm going to add a class. And again, make sure this isn't in your DB context. This needs to be outside of it. So public class appdb init. Let's see, which namespace is that in? So using, there's the one I need to add. Using system data entity. There, create database if not exists. And then I want to put in appdb context. That's what I want to have be the subclass. So then on here, static appdb context. There we go. So this is page 306 in the textbook is what I'm basing this off of. And I'm going to say database dot set initializer, and we're going to set this to the
So do note, wait a second there. App DB context, new app DB. Okay. So this is what I'm going to add in there. If this looks weird to you, you're probably not alone. I'll kind of explain what's going on here, but this is probably not something that you're terribly familiar with yet. Okay. Before I do that, though, just to make sure everybody's on the same page, open up your global ASX and just make sure that you don't, if you have a set initializer call, go ahead and comment that out here so that you don't have it in two places. Because if we're setting the initializer to one thing in one place and setting initializer to another thing over here, it's going to be, you might run into some issues. Okay. So this right here, what does it look like? What does AppDB context, what kind of thing does it look like that you have seen before? Looks like a method. Okay, what kind of method?
Constructor.
Looks like a constructor, right? In fact, if we look at this right here, which is a constructor, it looks very similar, right? Difference being here that I have the word public and the other place I have the word static, okay? So public's an access modifier. I'm saying anybody can call that method. Static is going to make this do something quite different, okay? So this is what we call a constructor here. This is a constructor. This is what we call a static constructor, okay? So a regular constructor runs when? When does that method run normally? Okay, when I say which object instantiated, which is when I say new AppDB context, right? When I see that word new is when I'm going to call that method, okay? This static constructor is called the first time I use the class, okay? The first time my code references that object, okay? That's when this line of code is going to get called. First time I use this class, that's when that will be called. Okay, that's what a static constructor does. So it happens actually before a regular constructor gets called. Does that make sense? I have to reference the class before I can actually call it. So this gets called as the class is being loaded, as we would say. It's called by the class loader. Okay. So what I'm doing is this database set initializer says use this class to update the database if there's a difference in the schema. Okay. If the schema is changed or whatnot, here's the logic that I want you to use. Okay. So there are a few different base classes that we can use there. So the one that they showed us, which is the drop database and then create, or there's this one. All of these are implement this interface, iDatabase initializer. That's what's important. So as long as they implement iDatabase initializer, that's where we can use them. So in that process, all of them have a seed method. That seed method is good for putting in some basic data that we want to be there when the website at the beginning of deploying the application. So that's one place to add in some quote-unquote seed data, and that's typically where we would create any initial users. Like if we wanted there always to be an admin, we'd create the admin there, or if we wanted there to always be some roles, we'd create the roles there in that seed method. Okay. So that's what that's about. That's that's making sure that this initializer is set up so that when it tries to get to the database and there's a change in the schema, what sort of behavior should it do? Because normally it's just going to complain. We're going to say, hey, there's a difference. I don't know what to do. So here we're going to tell it if there's not already a database, then create it. Otherwise, just leave it alone. Okay, so that's setting up our DB context. Okay, the next thing we need to do, now that we've created our DB context, we need to create our user manager. This is over on page 306. Okay, so the user manager is what actually deals with working with users. Okay, this is where we're going to do a lot of our stuff today. Okay, and a lot of our stuff tomorrow. So the user manager's got a lot of useful methods in there. You've got a create async, which will create a user. You've got delete async, which will delete a user. You've got update async, which is for editing a user. You've got these users property, which will let us go through and get all the users that are in the database, etc., etc. So anytime we want to do something with users, we're typically going to do that through the user manager. We don't actually do that through the DB context. So we actually use the user manager instead of the DB context when we're working with the users table. Similar thing's going to happen when we're working with roles. We'll deal with the role manager instead of working with the roles table directly. Okay? That's to, again, provide some separation between the actual logic that happens there versus our implementation of the business logic things. Okay? So those are all there. Now, a lot of that logic's already built into the user manager. Specifically, this user manager subclass already knows how to work with Entity Framework. So all we've got to do is add in just a little bit of code to make that work. So I'm going to add my user manager. I'm going to add it into the models folder. So I'm going to create a new class. And this is going to be the app user manager. This is going to be a subclass of user manager. It's going to use app user.
Sorry, so that was under models as well?
Yes, this is under models. The book puts it under the infrastructure folder, but I'm going to keep this under models because that's where the template builds it, puts it normally. So app user manager, you will see an error if you just put that in saying that you need a constructor. So let's add in public app user manager. This is going to take a user store of app users, call that store. Pass it down to the base constructor.
What is a user store?
So user store is a go-between between the user manager and the database. It's an intermediate layer. We won't actually do anything with it. Okay. What it's meant for doing is things like caching, so that you don't have to hit the database every time you want user information. So it's an intermediate layer there, and the reason that's kind of separated is to make that more reusable. So if you are working with, say, MongoDB or SQL Server, you have different ways of storing the data, whether it be to a text file or a SQL Server, things like that, then you don't have to swap out your user store class, is the point, or things like that. The point is to kind of put an intermediate layer there that deals with some of the complexities with different storage mechanisms and things like that. But we don't have to worry about it. We won't do anything with it directly. We'll be working with the user manager. Public static. I also need my create method, which I'm going to add in here. Public static app user manager create. And it needs to have that signature.
In the constructor, the book has iUser store. Do we have just user stores?
Yeah, it ends up, for at least for our purposes, the distinction between the two won't matter.
Okay.
There is some value to having it be iUser store, but I'm going to leave it there because it means that our role manager is going to be a lot more similar,
Okay.
a lot closer.
For app DB,
I put what?
for app DB context.
That's going to be your DB context, right? So that's what I've called my DB context subclass. Yours is going to be something else. So yeah, you can either put iUser store or user store there. It technically really should be iUser store, but it's going to make that easier to work with for what we're doing, because the distinction won't really matter for what we're doing right now. If we were doing unit testing, then we would care, basically.
Oh, all right.
If we were doing unit testing, I would care that it's a user store. It's actually just saves me typing at the moment to put it in there that way. Same thing with the role store.
Right.
So. Okay, so that's our app user manager. So just to refresh where we're at, we've created the app user subclass, we created the DB context, and now we've also created this user manager on top of that. Okay, but none of that have we really, so far in that process, we haven't told OWIN about any of those classes. So OWIN doesn't know, hasn't been configured to know how to construct those things yet. Okay, we do remember that we put in this startup config into our web config, which says, hey, here's where our startup class is going to be, but we haven't created that startup class as well. If I look at the code that's here, notice right here I'm saying OWIN context.get. Here I'm calling into the OWIN context, into that dependency injection container, and saying, hey, I want an instance of appdb context, right? So if there hasn't been one created yet, that's actually where it's going to go ahead and say new appdb context, is when I say get. If there's already been one created for this request, then it's just going to reuse it. Okay, so the next thing we need to do is we need to actually create that startup class. Okay, so I'm going to go into app start. I'm going to add a new class. We're going to call it startup. The other thing I'm going to do while I'm in here, I'm going to completely remove that namespace. So it's going to be just in the root. The startup class I don't actually want to be in a namespace.
Which folder did you put it in?
I put it under app start because this is code that's going to run when the app starts up. So we're going to call this class startup. In there, I need to implement a method. Here. So I have these things next to each other. Public void configure and it takes configure auth and it takes an I app builder. I do want to mark this as a partial class. And this is app. So this is what your startup file should look like so far. Okay. So now I want to actually configure the parts that I need. So app.create per OWIN context. And we're going to have it create the DB context. So app DB context. I need a using for that. Using my models, namespace, and create. Okay, so that's for the DB context. And I'm also going to add in one for the user manager. Create per OWIN context, and I need to do app user manager dot create. Now there I do need to specify app user manager. So what this says is if I want a database, if I want a subclass of identity DB context, I'm going to call that create method. If I want a user manager, I'm going to call that create method. If I want a role manager, I would call the other. I also need to specify how to log in. So I'm going to say app.use cookie authentication. So we're going to say new cookie authentication options. And curly brace, so create new object. The authentication type is equal to default authentication types dot application cookie. If we look at some of the other options that are there, there's a few different options for what we can set up as the type. Application cookie is the one we're going to use, which is, hey, I want a cookie that's application-wide. If there were other things like this, two-factor external cookie, if we're using different login mechanisms, we might use those. But since we're just logging in on our website and we're not hooked up to any other websites, that's what we're going to set it up as. And then finally I need to set the login path to be a new path string. Which points to account login. So all I'm really telling it to do there is to use cookies for authentication, and our login page is account login. That's really all that's telling it to do. Okay. So that should be enough. If I run it, I think it won't crash. App setting. Oh, okay. I think that if I go back here, nope, that wasn't it. App startup is value startup. I may have to put that into a namespace. So namespace authentication. This is just me testing to see if this will work. I'm not sure if this is the right thing or not. Namespace auth example, and then in the web config, well, that is weird. I wonder, configuration. There's the problem. Okay, so in order to make that work, let me just roll this back and see if that worked without the namespace. Actually, let me try that first. Okay, that works. So back to just startup and remove the namespace. Okay, so the catch was this here, as far as the configuration, I think that needs to be an uppercase app for app startup in your web config. And make sure that this method is called configuration. That seemed to be the problem, that it wasn't called configuration. Okay, that's what happened, yeah. Yeah, okay, so yeah, that method needs to be called configuration. That's the key thing. Is everybody running now?
Your startup file. Oh. Go to your web config. That's what that is. Go look at your connection string. You see you have it twice. Multiple active results. And one of them is wrong. So this one's multiple active result sets. That one's right. This one's wrong. Yeah. Oh yeah, you are missing something. Okay. You need to add a new variable there. Public static. First one was that was one. And then call create. And you say return new arguments.
Yeah. Yeah, mine.
Go back to the startup log.
What is wrong?
What's your error?
Did it run in what program?
Why is it not generating?
Hold that at the initialization method one says.
Yeah, that's exactly.
So this, change that to R.
That's
No,
just
this
your
means
regular one?
the name of your complex.
Well, there's only one.
I mean, that's just the DB complex.
It's just a constructor. I don't know why it's doing that.
User cannot be used as site.
I'm gonna cry so much.
What do you have? What's that app user agent? What?
I just must be.
Maybe my web configuration. I didn't change anything about it.
That's records that. Oh. See, it takes a
I don't know what this
active
user is.
demand. Not map feature. I think that's okay.
Oh, these settings are hard.
6 months off.
Yeah.
The three of us are getting the same error.
Okay. Okay. That's fine. So this error is actually, there's a few people getting that error. Brandon, you're getting that error as well. If you're seeing that error, that more than likely, that's part of why they put that in drop create table. Because there's a change in the schema at this point, and it's like, well, just drop all the data. So that's okay. We're going to fix that because we'll update the schema because we need to add all those tables that it needs.
Yeah, it's because it's like needs a key.
Yeah.
Yep.
Yeah, but it doesn't have those tables yet, right? So we need to make sure they get active.
If you're starting, and this is part of why I'm going to give you my project when I'm done with it, because if you're starting this out on an empty project, it's fairly easy to get the let it go create the table, and then you just drag and drop the schema definitions in. If you're starting with an existing project, unfortunately Microsoft hasn't provided an easy way to get those schema definitions. So you usually end up having to go create another project and doing that. So one way we can get those is we can actually get them from that template project that we created earlier today. We can actually pull those in from that template project that we created. So that's where we're at. So we're on page 309, and that's probably about as far as we can get today. So if you would, go make sure you read through chapters 13, 14, and then we're going to try and get as much as we can done of chapters 13 and 14 done tomorrow.